This is Euclid Book 3, proposition number 18, and what we're trying to prove here is that FC is perpendicular to DE. Now the first thing we have to do is we have to draw a circle, starting at point A, coming over here to point B, and going all the way through point C and coming back around to A. Alright, and then we have to find the center of that circle, which we'll use Euclid Book 3, proposition number 1. And then we have to draw a line from the center of the circle to its outermost edge, which becomes FC. And then we have to draw another line that starts at point D, goes through point G, goes through point C, and goes all the way down here to point E. See, there's point E there, C there, G there, and D there. And what we're going to say is this: DE touches circle ABC at point C. Here's circle ABC, A, B, C. And here's line DE, and it touches ABC at point C. Okay? Now, we're going to hypothesize that FC is not perpendicular to DE, but rather FG is perpendicular to DE. Well, that would mean that angle FGC was 90 degrees. That would also mean that angle FCG was acute. And that's by Euclid Book 1, proposition number 17. You need to go back there if you don't know what we're talking about. It would also mean that line FC is greater in size than FG. Well, you can already start to see the problem here because FC is not greater than FG, but we're going to hypothesize that it is. That would also mean that FC and FB are equal in size because all radii of a circle are equal. You have a circle, ABC, you have a line from F to C and F to B, and they're equal in size because they are radii of the circle ABC. But here's where everything gets really ludicrous. Now we're going to say that line FB is greater in size than line FG. And as you can see for yourself, that's stupid. So FG is not perpendicular to DE. The only line that is perpendicular to DE is FC. And that's what you're supposed to prove in this proof. Alright, I will tell you more in a future video, so stay tuned.